motion word problems. The last type of applied word problem that we'll talk about are motion problems. Whenever we encounter a motion problem, we are going to use the following formula. D equals R times T. Now what this formula stands for is the following. Distance equals rate times time. Certainly we could interchange each side of the equal sign and use the formula rate times time equals distance. So throughout the following examples, I will be using this formula. Let's take a look at a pretty straightforward example. Let's say you drove for 4 hours at an average rate of 55 miles per hour, and we want to find the total distance traveled. Well, let me write down my formula. Rate times time equals distance. When I do these problems, I'm going to draw a little chart. So I'll put R here, I'll put my T here, and I'll put my D here. And what we want to do, we want to fill in the chart with the appropriate values. So let's look at our example. We drove for 4 hours, so that's our time. So I'll put that in the time column. And I'll put 4H for 4 hours. And under rate, the R column is 55 miles per hour. Okay. Now if I want to know the distance, I simply multiply rate times time, and I get my distance. So 55 times 4, that is 220. And notice when I multiply straight across, my hour component is going to cancel, and I'm left with 55 times 4 miles. Okay, so this is the standard equation that we're going to use throughout these word problems. Let's do a little tougher example. Two airplanes leave Chicago at the same time and fly in opposite directions. One travels at 450 miles per hour, the other at 550 miles per hour. We want to figure out how long will it take for them to be 4,000 miles apart. Well, let's try to represent this word problem with a picture of some sort. So let's say that this dot represents Chicago, and we have one airplane going one direction, the other going the opposite. Now let's just label a little bit here. Let's draw a little airplane. So I've got one airplane going this way. Let's say that this airplane's rate is the 450 miles per hour. And we have another airplane going in this direction, and this airplane's rate is 550 miles per hour. Now, we want to know how long will it take for them to be 4,000 miles apart. So this distance plus this distance must equal 4,000. So I think I have somewhat of a diagram of what's going on in this problem. Now I'm going to draw my little chart. So we have rate times time is equal to distance. Now let's see, I have an airplane going 450 miles per hour, so I'm going to label that airplane as the slow airplane. I know 450 miles isn't slow, but certainly it's slower than 550. So I'll represent this airplane as the fast airplane. Now let's try to fill in our columns. Let's see. R, let's find the rates of each. Well, the slower airplane is going 450. The faster airplane is going 550. Now, we have to figure out what our time is going to be. Well, we're looking for the time. Actually, we're looking for the time that it takes for them to be 4,000 miles apart. Well, if they leave at the exact same time, the times are going to be equal. So how about if I let t be my variable time? And notice that the times are equal. This is the unknown quantity that we need to solve for. Well, I know that rate times time equals distance. So 450 times t gives me 450 t. That's going to represent the slow airplane's distance. Similar, rate times time equals distance, and that gives me the faster airplane's distance. Now let's try to figure out an equation. Well, I know that the total distance is 4,000. I know that this distance is 450 t. I know that this one is 550 t, and I know that they have to add up to the 4,000. And now we have a fairly straightforward equation. Now let's just try to solve it real quick. 450t and 550t, well, those are like terms, so I can add those together. Or 1,000t equals 4,000. Divide both sides by 1,000. So t is equal to 4 hours. So what did we find out? Well, it's going to take 4 hours for these planes to be 4,000 miles apart from each other. Let's try another one. Okay. Pete starts walking at 4 miles per hour. An hour and a half later, Kathy starts running along the same route at 6 miles per hour. How long will it take Kathy to catch up to Pete? Well, again, I'm going to try to draw some type of picture or diagram to help me figure out what's going on here. So let's say there's the starting point, and I have Pete walking along this path at 4 miles per hour. So this is Pete. Now Kathy is going to start running along the same path at 6 miles per hour. And we want to figure out how long is it going to take Kathy to catch up to Pete. So notice eventually Kathy and Pete will be going the exact same distance because that's when Kathy is going to catch up to Pete. So let's draw our little diagram, our little table. I've got rate times time is equal to distance. I've got Pete, and I've got Kathy. Now let's look at the problem here. How long will it take Kathy to catch up to Pete? So the unknown quantity that we're trying to solve for is Kathy's time. So over here on the side, I'll let t equal Kathy's time. Now I'll try to fill in the rest. Oh, let's try to fill in Pete's rate. Well, that's going to be easy. That's 4. Kathy's rate is 6. Now notice, this is the most difficult component to figure out here. Let's see if we can figure out what Pete's time is. Well, Pete starts walking, and then an hour and a half later, Kathy starts running. So Pete's actually walking for, let's see, an hour and a half longer than it takes Kathy. Well, if it takes Kathy t hours, then Pete must be walking t plus an hour and a half. 3/2 is the fraction for 1.5. So Pete's time is Kathy's time plus an hour and a half. Now notice, distance equals rate times time, so this distance must be 4 times t plus 3/2. This one must be 6t. Now let's figure out an equation. Well, the whole point of the problem is to figure out how long it takes Kathy to catch up to Pete. So notice, their distance must be exactly the same. So here's Pete's distance. It must equal Kathy's distance. So the equation then must be Pete's distance must be exactly the same as Kathy's distance, and we'll solve. Why don't we distribute the 4 through? Let's see, 4 times 3/2, I can cancel the 2, make that a 2, and 2 times 3 is 6. I'll subtract my 4t to both sides. and dividing by 2. I have solved for t. Now let's see if we've answered the problem. The original problem said, how long will it take Kathy to catch up? Well, t was the variable Kathy's time. That's exactly what we wanted to solve for. So Kathy's time was 3. It took her exactly 3 hours to catch up to Pete. Now you may want to review this segment of our lectures a couple times. These problems can be tricky, but if you look over these a couple times, it should make sense to you after a while.